Hey everybody, I'm MS Farzan, and welcome to this video on working with Phaser for digital tabletop game development. If you've been following along with my series on learning JavaScript for digital tabletop game and web development, this video will be a great entry point for the game development track of our learning. If you're coming to this video from somewhere else, it will still be a great entry point for learning Phaser for digital tabletop game development. Let's get started. As you can see, I've got the Phaser website open at phaser.io, and as it says on the screen, Phaser is a desktop and mobile HTML5 game framework, which is fast and free and open source, and I find it to be a really great way of learning how to make games using web technology. And Phaser, in general, I'll just tell you off the bat, is really fun and interesting to work with, and Phaser 3, the third version of Phaser, can feel like a lot of work in learning how to use it if you haven't used a web framework before to make games. And that's why I'm making this video series, as the learning curve can be pretty steep if you don't already have some familiarity with JavaScript and how to make games in general. Otherwise, it's super powerful in what it can do, and I find it to be a really great solution for making 2D games, and particularly tabletop games, and I'll explain some of the reasons why that's the case as we move forward. There are a couple of prerequisites in that I really would recommend that you've done a little bit of JavaScript training, even if that just means having worked through the previous videos in this series on learning JavaScript for digital tabletop and game and web development. And also that you have installed some sort of command line interface. We'll be using Git Bash in this video, and a code editor. I'm using Visual Studio, but you can use whatever you like. And for this video particularly, we're going to use a template that's available on GitHub. So it would be great if you have already signed up for a GitHub account and know a little bit of how to use GitHub. If you don't, that's okay. I'll walk through it. And I also have another video that I'll link in the description of this video about how to use GitHub and ES6 to create and to manage your code. So if we're on the Phaser website and we're thinking, okay, I'm going to install Phaser, we're going to start making games, I'll go to the download link and I'll see that there's under this guide of the JavaScript guide that we'll be using, we'll see that we want to I'm not in the right place. We'll see that we want to actually get ready by downloading the game, and we'll say, well, okay, I want to just download an editor like I'd be downloading Unity or Game Maker and just start coding. Phaser doesn't work exactly that way. There are some integrated development environments, at least one that I know of, that create a user interface for you to use in creating your games. But by and large, the way that you will be using Phaser is just by using pure code and then rendering that code using your own local web server in a web browser. And that can be a little bit complex in terms of setup and understanding how all of that works. We're going to skip some of those steps and instead use a template that's put out by PhotonStorm, who is the creator of Phaser. And the way we're going to do that is we're going to go to this page on GitHub, which I'll link in the description section of this video as well. It's at github.com/photonstorm/phaser3-project-template. And we may not understand exactly everything about what's happening here, but I'll explain it as we go along. Essentially, this project template for Phaser 3 allows us to clone or essentially download a template, install some dependencies, and then what it will do for us is it will scaffold a project for us, just a base project that we'll be able to play with. And it uses Webpack, which is a package that will watch all of our files and load them in a web browser. And when we make changes to that files, it will and save those files, it will automatically reload the page so that if we're making a game and we're playing it in the browser, we don't have to save our files, stop the server, restart the server, and just do a lot of stuff on the back end to make it work. If you're interested in how that back end stuff works, I recommend checking out the web development track of this video series is I'll describe more in depth about the front end and back end of web development. But in this case, what I'd love for you to do is just create a GitHub account. Maybe check out that video that I mentioned about GitHub and ES6, although it won't be completely necessary for this video. And then we'll come to this link, this button over here that says clone or download this template. And this is actually just a great best practice to know about JavaScript development and coding in general, as you'll be doing this a lot when you're working with different what are called repositories on the web. On GitHub, for example, when we have a template like this or any collection of files, you can call that a repository or a remote repository because it doesn't exist on your computer. It exists somewhere else. We're going to clone it so that we can create a local repository, one that exists on our machine. So I'll click clone or download, and I can just click this button to grab this link here and copy it to my clipboard. And now I'm going to move over to my command line interface, which, as I mentioned, I'm using git bash, which integrates some of the things that we'll need for GitHub. I'm using this on my Windows machine. You might be using something different, and that might require additional configuration on your part. And I'm going to move into my JavaScript folder, as we've done in previous videos, by saying, into my coding folder, cd coding. And then I'll move into my JavaScript folder, which is my preferred folder for keeping these things together. And you can put this wherever you like. It doesn't matter. We're just using the convention from previous videos. And I could also go into my cd tutorial -project folder. And if you're familiar with the command line interface, you'll know that you could chain that all together so that you would just have to use one command to get to that folder, but it doesn't really matter. And then I'm going to say git clone, and I'm going to right click here because if I press Control V and git bash, it will create issues for me. I'll hit paste. And what I'm doing by saying cloning is that I'm literally cloning the remote repository. And I want to download everything in it to my local repository. Create a new local repository on my machine. I press enter, and we'll see that it says cloning into its own folder, which is phaser3-project-template. And I'm going to navigate into that folder. And now that I'm in that folder, I'm going to take a look at the instructions of the template that I've just downloaded, which often you'll see like a README or some sort of documentation about what's needed. And I will get to have my first experience in using packages and installing dependencies. If you've already well, I should mention that if you haven't installed Node.js and haven't been following along this series, now would be a really good time to do that because we'll be using Node as our runtime for this whole project. So go ahead to check out Node.js and install it on your machine, get it up and running. And what we'll be using is what's called the Node Package Manager. Packages are dependencies that you might use in your projects to handle different functionalities for you. Right now, although we've installed this or downloaded or cloned this repository onto our machine, we haven't installed the dependencies that it requires to get to work. We basically just have a skeleton of what we'll need. So we're going to write, as you see here on this website, we're going to write npm install, which automatically installs the dependencies, and I'll show you where those are, how it knows what to install. We also see that it has a couple of other commands that we run from the command line. When we write npm start in the command line, and recall I'll have to be in this directory, the Phaser3 project template, the root directory for this project. It says it'll build the project and open web server running project. That just means it's going to start displaying my game for me in a browser window. And if I hit an npm run build, it will build the code bundler with production settings. That just means that it's going to optimize my code for deployment if I want to actually put my code on the web for people to play my game. We're not going to be handling that in this video. Perhaps we'll do that at another time. Okay, so now that I've installed my dependencies, I'm going to go into my code editor, and I just have this log.js file that we worked on in a previous video. You can just ignore it. We're going to go into our Phaser 3 project template folder, and let's look at a few things here. Let's first look at the index.html. If you're familiar at all with web development and HTML, you might be expecting a lot more stuff in here. There's not much here that we can do with, and we don't really need to pay attention to it because these files that are being used for development have not been optimized for the deployment as I just mentioned. So if you were to build your files, you'd have a more robust index.html, but we don't need to worry about that right now. Another file that we want to look at is the package.json file. JSON is a format of storing data, and it in it contains a lot of stuff that we won't deal with in this video. I just want you to see that under the dev dependencies section of this file, we see things like Babel, we see HTML Webpack plugin, we see the Webpack CLI, and these are the dependencies that we just installed. You might want to take some time as your homework to look into each one of these and get a better understanding of what they do. But essentially, they allow us to run our code the way that we want to, and increases the functionality of our development process. Most of the meat and potatoes, or if you're vegetarian, potatoes and potatoes, or like field roast and potatoes of our project is going to be in this src or source folder. If I go into the index.js file, we see, if you were going to follow along with the Phaser tutorial, if you were to go to Phaser learn and then getting started or make your first game, you'll see that this will look very similar to the code that you will generate in the process of making your own first game. We'll look at it one by one, line by line, so that we understand better, even though if you have some background in programming, whether from my videos or you've done some JavaScript programming through some online tutorials, each framework that you use or each engine, whether it be a game engine or otherwise, will have its own particularities or idiosyncrasies of how it wants you to do things. And so the learning curve for Phaser can sometimes feel pretty steep when you're trying to learn not only JavaScript, but also you're trying to learn, how Phaser wants you to do things. The first thing to look at here is that this index.js is our main entry point for the application that we're creating. It's the place where everything starts. And at the top of this file, we're saying import Phaser from Phaser and import logo image from this path. Importing Phaser is, we need to tell our project that we want to use Phaser, which itself is a dependency, and that's the syntax for doing so. And we're also importing a logo image from, you see this path here, which dot means the, in terms of a path, it means the directory that I'm in, /assets/logo.png. Let's go into the assets directory and see that there's a logo.png, a logo image that is being imported so that we can use it in our code. Now we see after this section of imports, we see a code block that begins with const config. A constant is like a variable. It is a variable that more or less is going to stay constant throughout the entirety of my code. There are some exceptions to this that we don't need to discuss, but const is, let's just say, a more concrete of saying let or var config. So we're storing a bunch of information into our config variable or our config constant, and this config constant is an object as an object data type. Within the config data type, we have our config object. We have several key value pairs. The first one is type phaser.auto, and the parent is phaser example. The width and the height are 800 by 600, and there's a scene object, which is also a key value pair, which says preload is preload and create is create. What I want you to pay attention to right now, and all of this stuff is in the Phaser documentation that is probably worth looking at some point, it's just the width and the height of this project. That's going to be your the dimensions of your project, and that's in pixels. So if you wanted to have a 1920 by 1080 project, you could change that here in this configuration. We're just going to leave it as is right now. Then we create a new constant or a new variable called game, and we make that equal to new phaser.game, and we pass in the config object as an argument. This is the way of saying that we're creating a new variable, we're initializing a new variable called game, and we're making it equal to a new iteration or a new copy or clone of the Phaser class, a new object that is we're deriving it from the Phaser class that we imported at the top of our script, and we're passing in config as an argument, essentially saying that we want this new Phaser game to derive from all of these options that we just initialized. That's Phaser's way of allowing you to customize your game based on certain parameters. In each of your Phaser files, when you're working with Phaser, you're going to have three functions that handle the functionality of, no pun intended, of your game for you. Those three functions are preload, create, and update. Preload is, as the name sounds, is where you're going to preload any assets that you might have. Like if you have many different cards, like images or sprites that you'll be using for your card game, or tokens that you'll be using for your board game, you're going to want to preload them here in the preload section of your code. In terms of create happens right as the game is played for the first time. So to create those cards on screen, or to create them, create your tokens on screen, or handle other functionality, you're going to do that in between the curly braces of the function create. And then if there are things that happen during that Phaser needs to check every frame for, so like let's say instead of making a tabletop game, you are making a platformer, and there are enemies shooting lasers at your main hero, then you would be tracking the enemy movement or the movement of your character every frame, or almost like every second, by putting that into the update function of your code. We're not going to be dealing with the update function much at all in our programs, because all of our code is going to be written pretty systematically, and not we don't really need Phaser to be checking every frame for anything. We're going to be working on user input, like when a user clicks the mouse and drags something, we want something to happen. So we're working more with events than we are with checking something every frame. You don't need to worry about that right now. In our preload function, we see that Phaser has loaded this image, which is the asset/logo.png. And let's return to why it's written as this.load.image, and what the syntax looks like in just a second. In our create function, we create a constant called logo, and we say we want to add an image to the scene, which is, and we provide certain arguments to it. And then we see this thing that's called this.tweens.add. We're not really going to work with this, but I'll show you what it's doing, just so you have an idea. So there are a couple things to notice here in the syntax that perhaps you haven't encountered before, either in my videos or elsewhere. Rather than saying creating a, let's say in the logo aspect of the, or the logo variable here, we say constant logo equals this.add.image. Why wouldn't we just say like image or something like that? The reason why is that this file that we're looking at, the index.js, is just a template of, or like a factory of what we want to create. It's not the actual code that's going to be running at runtime. If you've ever worked with classes in JavaScript or another programming language, when you create an object, when you have a class, you don't actually use that class itself to do any work for you. You use that class to create an object that derives from that class, almost like a factory. And that's similar to what we're doing here. We're not, so if we just say that we want a logo to be equal to some constant logo equals some image. When Node runs our script, runs our code, it's not going to know where that logo exists. We want to say that it's or what is doing the work on that logo. We want to say that it is this version or this instantiation, this clone of this class or this object that this class has created. We want this very thing that we just created through code to do some work on this card or this image for us. And that's why we say this.load.image. We're saying this very object that has been spawned in this session of working with Phaser, we want this thing to do work for us. It might not make sense why we would do that right now, but it will make more sense when you have multiple different objects that have been created and multiple classes that you're importing and exporting elsewhere, and that's your way of signifying to Node.js or whatever your runtime is, which object you're talking about. In this particular case, we say that we want this Phaser scene to load an image, and we're giving it the name logo just as a shorthand. We say that we want in my application, I'm just going to call this image logo, and after the comma I see logo image, and that argument is a reference to this logo image that we imported here at the top of our code. Not so important right now. We actually won't be dealing with images in this tutorial, but just want you to see that that's how that's the syntax that Phaser uses to preload an image so that it's ready for use, and you give it a name and you say where it's coming from. And if I, with Visual Studio, when I mouse over this, it says the reference is coming from this import that I have up here. In the create function, I have the constant logo. I'm saying this scene right here that I've just created, I want to add an image, and the location I want it to be added is at the X and Y coordinates of 400 and 150. And what is the image that I want to add? I want it to be this logo that I just preloaded. And then the tweens part we'll see in just a second. Okay, great. So that's the code. So what do I do with that? Well, I go to back to my command line interface, make sure that I'm in the root directory for phaser3-project-template, and I'm going to run, where did we see this? I'm going to run npm start. That means Node package manager, the package manager that is bundled with Node.js. I want you to run the command start, and where this command lives is in our package.json. If you look under scripts, you see npm start. It's going to run this much longer code. It's basically going to spin up a server for us using Webpack, and then Webpack is going to, the dependency that we installed, is going to watch our files for changes and restart the server when necessary, when it sees a change. So I'm going to write npm start, and it's going to do some stuff for me. I always want to use Google Chrome. I'm not sure why I'm being asked that right now. And then it automatically opens a web browser for me, and we see this Phaser logo bouncing up and down. Let's take a look to understand what's happening here. So if you look through some of these lines of code, you'll just see that npm has given us some instructions for what it's doing. And what it has done is that it has built my files for development. It has created a web server for me, and it has that web server is serving files at the local port 8080, And so it has also done me the favor of opening a web browser and navigating to localhost :8080, which where the server is serving files. If it didn't do that for me, I could just go open a web browser and say localhost 8080, and I would see the same thing. Now, what it's done is it has created the Phaser logo for us on screen at 400 by 150, 400 X pixels and 150 by the Y pixels. And then this tweens thing is essentially allowing us to bounce this around. That's about it. That's our Phaser template. It might seem like a lot of work to get to this stage, but once you've done it a couple times, it's pretty standard. And I think, at least for me, it's the easiest way to get a project up and running. Later on, when you start deploying, you might actually remove Webpack and you won't need to use it. But I think in terms of development and programming, like a real programmer would program, I think it's a really great way of learning a bit about the JavaScript ecosystem and how the workflow generally works. You could install an integrated development environment for Phaser that allows you to just like click buttons and put things on screen. I find this to be a much more robust way of not only learning how to use Phaser, but also learning how to program and how to navigate the JavaScript ecosystem and general programming ecosystems as well. Okay, so let's delete some of this stuff and see what happens. So I'm going to delete this tweens thing. I save it, and we'll see that that npm has restarted the server, and now we see that it's no longer bouncing up and down. And then I'm going to delete the logo, and I don't need this preload, and that also means that I don't need to import the file at the top of my screen either. Save everything, and then now I just get this blank screen. Okay, cool. We've done pretty much nothing. I don't need this logo either. You can play around with it if you like, but I'm not going to be using it, so I'll delete it. Now we have a nice, clean, empty scene here. Okay, let's consider what we might want to do as our first project in diving into tabletop game development with Phaser. Well, the first thing that I might want to do, for example, is to be able to create a token or a card or something on screen. Let's say that my game requires me eventually to have 5 tokens that I can move about at will. That's actually pretty easy to do with Phaser compared to other game development platforms or engines. One of the things that I really like about Phaser is your ability to create things on screen and make them draggable and droppable with pretty much very little effort compared to other game engines. All game engines have their own things that they're good at, but if you take a look at what we do here and then try and do it in Unity, you can watch one of my videos on coding in C# and Unity and see that the drag and drop script for just dragging and dropping simple objects is pretty complex compared to what we're going to do here. So that's one thing that Phaser is very good at. So let's say that in the create function of my game, I don't need to preload anything right here. I'm going to say this.add.rectangle. Let's say, and what's great about Visual Studio is that it will show me as I'm writing like the things that I will need in terms of parameters for a particular function. I'll say 300, 300, 100, 100, and then 0x00, 00, FFFF. So as we can see as I'm typing, this might be a little bit small on your screen, but it shows me the parameters are the X and Y coordinates, the width and the height, and then the color that we want to have, and then some other parameters. All of this is available on the Phaser documentation. I'm kind of skipping some of that just to show you the germane parts of our code that we need to know. But if you go to phaser.io and you go to the examples, and then like, let's say I wanted to create a rectangle, I could search for rectangle here, and then it would show me like different ways to deal with rectangles or how to create them. Here, game object shapes rectangle. When I click on it, I see that I see how I could create a rectangle and store it in a as a variable. And these examples I think are really helpful. You can also go to the API documentation, which is much more fully fleshed out, but it can be a little bit intimidating because like when I type in rectangle, for example, I get all this stuff and I'm like, I don't know, let me just click on the first one and see if it gives me what I want. But if you just need a quick and dirty way to do something, check the examples first. So all of these parameters will be there, and we'll explain to you that like, oh, okay, the first argument that I'm putting in here is the x coordinate, then the y, then the width, then the height, and then the color that I want. And I say this.add.rectangle and supply those arguments. Save it. Go to my project, and I see that, okay, I've got this rectangle here. It's a little big for this project, so maybe I'll make the project a little bit bigger. Let's say we want it to be 1,000 width and 800, some weird dimension that we'd never see on screen. Okay, that's a bit better. And then instead of this starting at 300 by 300, let's say we want it to be a little bit lower on the screen. So the y coordinate, let's make that 500. Okay, not quite far enough. Let's make that 600. And this is, the life of a game developer, especially when you're doing everything through code and not, drawing it on screen. And let's move that to the left just a little bit. Let's make that at 200 at the x coordinate. Okay, that looks really great. Okay, and I make cyberpunk games, so I like this this cyberpunk blue color. You can choose whatever color you want. If you need like a hexadecimal value, you can just Google a color that you want and see exactly what the value you need to make Phaser happy. And then let's also say that I want to move it around. Well, I have to do a couple of things to make that happen. I have to right at the end of this code, right after the parentheses, I'm going to chain a command by saying dot set interactive, and then that. Ooh, let's see what it says when we it gives us some more information about the callback. Not to worry about. That just lets, putting the parentheses as a reminder, lets Phaser know that this is a function that I'm calling. And set interactive is just a base function that I have to call to make anything interactive. I can't actually do anything with this right now, as you see, if I'm trying to like move it around. What I have to do additionally is say this dot input. Okay, that does not say at all what I thought I was typing. This dot input dot on. So we're saying this in this case is the scene, the Phaser scene that we're working in, and we're using the input of the scene, and we're saying on drag, comma, and then in another parentheses, pointer, comma, game object, comma, drag x, comma, drag y equals arrow curly braces. Okay, that's a lot to take in. This first argument, drag, is Phaser's way of saying when the input system in our game engine in Phaser detects a drag event. like when I'm trying to drag something, you can't see, but I'm clicking and dragging. When I try to drag something, that's called a drag event. When that happens, then use the pointer, which is my mouse pointer, and the game object, lowercase g, big S, big case, or uppercase O. Game object is whatever it is that I'm trying to drag, right? In this case, it's going to be this token. And then drag X, drag Y, you'll see that that means the X and Y coordinates of the pointer as it's dragging something. So when something's dragged, that's a drag event, and use these different parameters, the pointer, the game object that's being dragged, and the X and Y coordinates of the of whatever is being dragged. Then we see this arrow and then our code, which we might not be familiar with. I think it would be a great idea for your homework to either watch the video on ES6 and GitHub that I've linked in the description section, or just look up arrow functions in JavaScript. It's just a different way of doing a similar thing that we probably already know how to do if you've watched my other videos, or if you've worked with JavaScript at all. Like if we say let new function equals function parameters, and then it takes a string called new string, and then we have a function that is almost identical to saying let newer function equals new string. Those two code blocks or functions are essentially identical. It's just a shorthand way. Arrow functions are just a shorthand way of dealing with functions or declaring functions. They also do something handy for us, which is storing this. But we don't really need to talk about that right now. But we will be using this syntax for some of our functions, as they will obviate the need to do some other tomfoolery to make them to make our functions work. Worth looking up for your development as a programmer, but not necessary for us to talk about right now. Anyway, we digress. So within this function, we're going to say game object dot x equals drag x, and game object dot y equals drag y. So when Phaser detects a drag event, it should make the x coordinate of the game object equal to the x coordinate of the dragger or the pointer, and the y coordinates should be the same. That is a long way of saying when we drag something, make sure that it follows the mouse. So now I'm going to drag this around, and nothing's happened just yet, because I need to do one more step here. And under this line where I create this rectangle, I'm going to say this dot input dot set draggable, and then something. We've created a rectangle, but it would be really useful for us to give it a name so that we are able to manipulate it at a later time. So we're going to say this dot new rectangle, or let's call it token. This dot token equals this dot add rectangle, so and so whatever, and then this dot input dot set draggable this dot token. Remember, this dot token is a way of, it's almost like us saying let token equals blah 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 whatever, and then using token elsewhere. But we have to say this, or in some cases we have to say this, so that it knows, so that Phaser and Node know which token we're talking about. It's not some abstract token that exists elsewhere. It's this token that exists in this scene. All right, save it and start dragging. And now our thing moves around the screen. Cool. That's great. We have a token that moves around the screen, which is awesome. One note is that there might be some cases where things go wrong or we're not sure what's happening, and we might want to log to the console to say that, like, hey, is this even working? Are you detecting inputs from my mouse? So we could say this input on drag, when it starts dragging, we could say console.log dragging, exclamation mark, and end that with the semicolon. And now I can, in Chrome, I can say Control-Shift-I, or I can say F12, and it'll open up this console in my web browser. And you can see that it's already let me know that it's running Webpack and Phaser. And then when I start dragging, it'll show on the right-hand side here in the console that it's logging to the console dragging because I've told it to. So for example, if I had forgotten, let's comment out this code, and I haven't set it draggable, and if I didn't have the console open, I'd be trying to drag this, and I'm like, why isn't it working? And I hit Control-Shift-I or F12, and I see also here that it's not some other issue. It's that I'm not even logging to the console that something is dragging. I could go to the Phaser documentation, to the examples, and find the input section, and then find the mouse section, and see, like, what is it? Mouse down, for example. I could go to the mouse down section and see. Actually, they've done it for us here. They've said this.input.on pointer down, console log down. So whenever somebody clicks the left mouse button, then it will log to the console down, or in our case, we've been logging to the console dragging. So you could see, is my input system working? Have I put maybe I didn't put this function in the right place, and that's one way of doing it. Okay, let's uncomment this so it works as we wanted to. So let's do a couple of other things, and this will prep us for another video in this series, which is a bit more robust in terms of actually creating a card game that will a multiplayer card game that will work for us. Let's do two things here. Let's on the one hand create a function that will allow us to or create a for loop that will allow us to create many tokens at one time. And then let's create some text that somebody can click on that allows them to create those tokens when they click on that button, so that it's not like we just start our game and then all of a sudden there's just one token here. So very simply, we can just write for let I equals 0, I is less than 5, I plus plus, and then we'll open a code block and we'll put this code right in the middle of it, save it, and now we have them, but they've all dropped on top of one another, which is, I mean, that's fine. There's nothing wrong with that, but we've successfully created 5 tokens that if I just restart the page here, they're all on top of one another. If I wanted to programmatically set them aside, I could notice that, okay, they all are being created on the at the 200 pixel coordinate of the in terms of the x value. So maybe I'll just say instead of 200, I can say 200 plus I times 50. Make sure to close the parentheses, and then now it should create each of them at starting at the x coordinate of 200 pixels, and then it's going to add I times 50, and you'll recall that I starts at 0 and it goes up to 5, so it should be 200 plus 0 times 50, so 200 plus 0, 200 plus 50, 200 plus 100. So sequentially, we're moving from left to right by 50 pixels each time. And it's kind of worked. It hasn't exactly worked. We need a little bit of a longer value here. So let's say I times 100. And I've saved it. Still not wide enough because my my rectangles are 100 pixels in width. So let's say 150. Oh, that's perfect. That looks really good. So I've successfully created 5 pixels, 5 tokens on the screen here at the bottom, and now I can move them around at will. Very cool. And then let's say that I don't want to do this at the beginning of my game. I want to create a some sort of text. Phaser's not really good at creating buttons. You have to kind of like maneuver Phaser to make buttons for you, or you can look up a button tutorial to create that for yourself. Let's call it, let's just, before all this, let's create a new variable called deal text, and we'll say this.deal text equals this.add.text. And if you wanted to check out how to work with text, you could go to the Phaser examples. And where does text live? I think in the game objects section. Yeah, you can go to text and see like how to create text, or how to change the font, how to make multiple lines of text. Here, just really simply, I'm saying this.add.text. And then it's going to be at the 75x coordinate, 350 y coordinate. And then I'm going to create an empty array, and in it I'm going to put a quotation marks, a string that just says deal cards, and that will create my text for me. And let's just save it and see what happens. Go back to my, okay, great. It creates a deal, this text right in the middle of my screen that says deal cards, or the middle in terms of the y coordinates, deal cards. It doesn't look too pretty to me, and it doesn't look very cyberpunky. It's kind of like, looks like what a journalist would use on a typewriter. So I'm just going to chain a couple commands here that Phaser provides us and say dot set font size, and the capitalization is important. I'm going to change the font size to 18. Dot set font family. Going to change it to, in parentheses, Trebuchet MS. You can look up whatever font you'd like to use. Dot set color, and I will use the hex number hash 00FFFF. And I'm actually not sure why there's a different representation of the hex number within this as an argument versus when we created our rectangle. I'm not sure why Phaser requires or prefers it that way, but that's just the way of doing things. And then dot set interactive, because we're going to want to set it interactive. Okay, and now save it. And now we see that we have this cyberpunk blue deal cards that's a little bit bigger and has a different font. Okay, can't do anything with it yet. So what we need to do is we can use the input system, similar as we did before, but a little bit different, by saying this dot deal text dot on, and then in parentheses pointer down, which is the event that Phaser is looking for. When the pointer is down on the deal text game object, comma, and you could write this as function, or you know what, let's keep our convention. Instead of saying function, we'll just say parentheses, and then create an arrow function here. and we'll say that we want to call this dot deal tokens with parentheses. That says that we want to do a when the pointer is down, or when it's clicked on the deal text, we want to run a function called we want to call a function called deal tokens. We haven't written that yet, so let's write that right under here, and we'll say this dot deal tokens. We could say function, or we could just put a parentheses here and write an arrow function. And let's say all we want it to do is say console.log pointer down. Okay, so when the pointer is down over the deal text text or game object, we want the console to log pointer down. Let's do that, and that's working great, as we can see on the right hand side of our screen. Great, so that we know that's working, and that's something that can be helpful in your own development, is just make sure that a thing works before you add functionality to it. And then instead of just having this pointer down thing, let's move this whole thing, the whole code block, our for loop, let's move that within these curly braces. So when we start our game, there should be nothing in it. But then when we mouse over the deal cards and click, it should create these tokens for us. And now we can drag them around. And all of this is being logged to the console because of the work that we've done. Well, that's pretty cool. I like that a lot. Let's say that I wanted to make a little bit more interactivity for my deal cards text here, so that right now I don't really know that I'm able to use it for anything. So let's say that, let's add a little bit to our input system, and we'll say this dot deal text dot on pointer over, which is another event when the pointer is over the deal text comma arrow function, self dot deal text, not self, sorry, that's from carryover from another thing, this dot deal text dot set color, and in parentheses a string that is hash ff69b4. That's a nice cyberpunk hot pink color. You could use whatever color you like. And this dot deal text dot on pointer out comma parentheses arrow function, this dot deal text dot set color, our normal cyberpunk blue of hash 00FFFF. So when the pointer goes over the deal text, change it to pink, the text to pink. When the pointer goes over, goes out from the deal text, change it back to blue. So now when I mouse over the deal cards text, it turns to cyberpunk pink. When I let it go or move away, it goes back to blue. And then I click on it, and I get all my tokens here that I can now drag around, which is great. Very cool. So that's our basic functionality for our tokens, displaying them on the screen. If there's some variability there, you could say like if we didn't want to just have 5 tokens, if we wanted it to be dependent on some other value, for example, you could say this dot deal tokens in our deal tokens function. We could say we could pass to it a number parameter, and then we could say I is less than number. So we're saying that we don't want a fixed number here, which is the number that I should be less than, or the number of tokens that should be created on the screen. We want to have a number of tokens that we determine at a later time. And then here in our deal tokens function, we could change that. We would need to pass in a number here, and we could say 5. We could say this, we want to deal 5 tokens as this number, and we'll supply 5 as an argument. And then when we deal cards, we get the same functionality as before. But then if we said 4, and it reboots the page for us, we would get 4. So that's a nice and clean way of handling without having to say like deal 5 tokens function, deal 6 tokens function. We could just reuse this code as necessary if we needed to do that. Of course, we'd also have to change the layout of our screen and our user interface, because if I say I want to deal 10 tokens, then it goes off the screen. So we'd have to manage that somehow. But for now, we can just leave this at 5. And it works great. And I can drag them around, and I have tokens on my screen. I find this to be really useful for like running simulations or just having things on the screen. Like if I added text to these things, which you could do, then I could have very basic tokens on screen that I could move around, or maybe use Phaser's randomizer to show me like the probability of certain tokens appearing on screen, and also just having a visualization of how these things can work, rather than having to create them myself on an actual tabletop and either print the cards out or print the tokens out or write them out or whatever. This is just like, once you get this up and running, it's so much easier to work with. And in fact, another video in this series, which I encourage you to check out, although it might take a little bit while to work through, because there's a lot more concepts than this very basic level than we're working at here, deals with creating a multiplayer card game using Phaser and another framework called Socket.io, and it will work through the steps of similar to what we've done so far, but adding multiplayer functionality so that I can open another web browser, and not only am I getting cards on this side of the screen, so are you, but I see your cards at the top of the screen and vice versa. And it also will help us to segment out our code into different scenes. Right now we have everything just in this one scene. If we wanted to have hundreds of lines of code, that would become untenable pretty quickly in one scene. So in that video, we'll segment it out into different scenes and import JavaScript classes, using JavaScript classes to import objects into our scene. And we'll also use other ES6 conventions to do so. So it will cover a lot more in-depth information about what we worked on here. And again, I highly recommend checking out the video on ES6 and GitHub in creating and structuring your code, as it can really help you in your development as a programmer. I hope this video has been helpful for you. If it has, please do me a favor and like it and subscribe to my channel. I'd also love for your help in spreading the word about my books and games by going to entromancy.com or nightpathpub.com/entromancy. Please share that information with others, and we'll see you soon.